Okay, so we'll go ahead and get started here. My name is Jeremy Crookshanks. I'm the product manager for hydraulic and lube filtration here at Schroeder Industries, which also includes accessories, which is where we group our tank optimization projects. This is a short webcast on our approach to hydraulic reservoir design, also known as tank optimization. We just wanted to take a minute, go through our approach, and for everybody's information and education. So, as far as the tank optimization projects go, they really start with a complete partnership. So why is optimization necessary? This is just a few starting out here. So we have the global competition, which relieves the cost pressures and the need to be more energy efficient. Then you have the legislation side, which is energy efficiency and tier 4, tier 5 engines. So with the tier 4 engines, you're losing a lot of space on your machine with equipment that goes on those machines to clean up those emissions. So with that, everybody's shrinking the size of a lot of their hydraulic components where they can. A lot of this, if it's not done properly, can lead to a lot of reliability problems that we hope to help our customers sort out with our experience on the optimization and the filtration concepts for hydraulic reservoirs. We're becoming more and more experts on this every day. We're up to roughly 250 plus tank optimization projects company-wide. We have the experience, we have the know-how, we have the simulations, we have the equipment. We really want to partner with our customers to bring these projects home and really help our customers, not just sell them a commodity here. Starting out with the overall optimization project, the first step is a review with the team. We talked about that partnership a little bit beforehand. A lot of the times people won't recognize the value of a tank optimization project because they believe that a hydraulic tank is just that steel box over there that holds the oil, where in reality it can be a living, breathing key component to your hydraulic system. The traditional approach to hydraulic tank design, people look at the flow rate, they look at rate of return, they look at total system volume, they look at their temperatures, how big they think they need to resize their reservoirs to dissipate that heat versus the ambient temperature. So that's how they traditionally look at it. We look at it a little differently. We try to look at it a lot more in depth with some of our simulations and everything. We look at the geometry of the tank. We look at the flow path through that geometry. Is the flow actually reaching all four sides of that tank? It's not just what your return flow rate is, but it's also what the path of that flow is and what the pressure contours and the velocities are in that tank to help design a complete overall system. So the faces of this to our direct customers are the product ability to providing complete tank package. We're going to reduce that assembly labor cost. We're going to provide a lot of value to the end customer. We're going to provide their compliance and reduce field issues, that kind of thing. We'll get a little bit more in detail into some of these things, as it goes on. But it also adds a marketability to promote this stuff to your end customer. A lot of the stuff comes with this as a weight savings or a space savings on your machines. If you save that space and weight in your machine, what can you do with that space and weight? A lot of the times we don't know as the tank supplier, but we've had customers add an extra winch or add an extra jib crane or something along those lines if they're up against DOT regulations. What they can do with that to add value to their end customers can also be a very large selling point. So after we get the review, we get all the details. The first thing we're going to do at Schroeder Industries is we're going to bring this into the FCC and we're going to run a simulation. With our simulations, what you're going to see first and foremost is, we want to look at flow. We want to look at de-aeration. We want to look at sloshing. And, a lot of these things are on mobile equipment. The tank goes back and forth a lot, which can generate a lot of air and a lot of different types of issues, cavitation issues and that kind of thing with your pumps. We'll look at the thermal aspect of the tank. Is it dissipating as much heat as it could? And then we'll also look at structural with an FEA analysis. And is it designed the way it needs to be designed? A lot of times if you're just putting 4 pieces of steel together, you use 1/4 inch where it could be you're looking at what you typically do versus an optimized view of it based on how much oil is actually in the tank, what supports are in the tank, are the baffles in the tank properly, not only to direct the flow direction, but also structurally enhance the tank to where it's as sound as it can be with as less materials as possible. The first one and the big one that we would generally look at is the flow analysis. Right here we have a baseline flow of one of our tanks, and what they were generally doing was they had just a standard filter with a down tube that just sort of directed the flow away from the suction strainers, which you can see on the right-hand side there. But in reality, that wasn't providing them the same type of optimization that they thought they were getting with it. You see here, it's kind of hard to see, but in the simulation on the right, we added a baffle and then did a diffuser in the tank. So it really spread out the flow of the oil a lot more, and we were able to reduce the size of that tank by 10%, but also add some key features that help this tank reduce heat and de-aerate the oil. The next thing that we want to look at would be the space and the material proposal. There's a lot of different ways that you can look at these tank optimization projects, and there's not a lot of one-size-fits-all solutions. A lot of these hydraulic machinery nowadays is very complex. We really want to get a good view of how our customers use their tanks, how they use their filtration, what suction ports are they running, what case drain lines are they running, what can we do overall versus just a Me Too tank scenario. So this one is a baseline where we were able to use a different style tank and reduce the overall volume on the machine by 35% and shrink the tank down quite considerably. This is sort of a simulation of this exact setup where you see on the left, that was the customer's old system, and then on the right, the two ones on the right, and the one in the middle is with no reduction in volume, and then the one on the right is with a 20% reduction in volume. So you see in the simulation with the customer design tank, it's very turbulent inside of the tank. There's a lot of sloshing and everything going on. That's all created by the return flow in the filter, whereas with the new Schroeder filters that have the patented window technology and the inside-out flow, you can see how crystal clear the tops of the tanks are. It's not creating that turbulent environment that won't allow your fluid to de-aerate. The next step in the optimization process is also a laboratory test. So we can prove it out in the lab, at the computer, on the simulations and everything, but we also have the ability at Schroeder Industries to take it to the lab and hook it up to your exact machine or to just one of your tanks, run some simulations. So here we see that we're taking these simulations, we bring it to the real-world test equipment, and we run it with your specific machines in mind. This is one of our simulators here. We have the ability to inject air, then measure the content of the air, and see just how well a specific tank is de-aerating. We can also measure the temperature, see how well it's dissipating heat, all of those type of analysis real world in the laboratory at Schroeder Industries. So this is a real world video of the tank that we optimized. The one on the left is a customer's tank with just an inline filter located outside the tank, and then the one on the right is the Schroeder Industries tank with the inside outflow optimized version with the window type filter. You can see just how violent the one on the left is reacting to the roughly 75 gallons a minute return flow, where the one on the right, you could basically water ski across the top of that tank with with no problems at all, instead of trying to surf on the other one. You can just see how different small changes in a tank design can be. Here you can see the one on the left is also calmed down, but you can see how much whiter and milkier the tank is. That's all air that was generated from the turbulence that was just caused in that tank from the previous setup. So these projects have the real ability to increase machine longevity and hydraulic component system life for exponentially. That being said, we have the ability to do those real-world laboratory tests, and then we also have the ability to do the field tests. So we have a mobile turbidity sensor, which can measure the amount of air that's in your hydraulic system. So here is an excavator that we brought into our tech center. We hooked it all up to the appropriate sensors and everything. They were actually able to run the functions of the machines and get a real-world test on this particular machine. From that real-world testing, we can get some baseline data. You see here the red line is the amount of air content in the original design, and then the green line is the amount of air content in the Schroeder optimized design. Even on these air bubbles, even if they're just micro-sized air bubbles, those air bubbles going through your piston pumps and your valves and everything are causing degradation of your oil and decreased lubricity against your wear surfaces. So that's really going to cut down on the overall life of your hydraulic components. So this is just an example of one optimized tank versus a non-optimized tank. You see in our system we have the ability to start an air injection and then stop the air injection. So we injected air for about 2 minutes into the tank. We stopped the air injection about the 3-minute mark here on the graph. And then you can see how long a non-optimized tank took to de-aerate. It took about 35 minutes for all that air to work its way out of the system in a non-optimized tank. Whereas the green line you see there is the Schroeder Industries optimized version, where it took just about 3 minutes, from the 3-minute mark where we stopped the air injection to the 6-minute mark where the air bottomed out. You can see it took about 3 minutes versus 35 minutes. So a dramatic reduction in air content in the oil. So this is an additional example of this type of thing. You can see across the bottom here, that is one of the tubes that is in our lab test machine, and what that's showing is the air bubbles that are going through that tube as it returns back to tank. So you can see it starts out clear, smooth. We start the air injection, it turns quite milky white, and then as it runs out over the 30-35 minute window, it goes back to clear. But in this setup, it takes 35 minutes for that to happen. Whereas on a tank with a good air separation layout and design, you start at the 3-minute mark, you see the air bubbles coming through when we inject them, but then it never even has the ability to turn milky white. The air is deaerated in the tank so quickly. So that's just one example of what we're able to accomplish at Schroeder Industries. Along with the optimization projects are aftermarket products that go on these tanks. So we have the ability with our tank designs to put the patented element technology in there. You guys have heard of GeoSeal or the GH patented designs. So these aren't just geared towards aftermarket revenue potential. It really does with these quality protected Schroeder elements versus buying a $5 element from down the street. It really helps with your overall cost of ownership of your machine. It helps with your hydraulic warranty claims for OEMs and customers of that nature. A little bit more on this. At Schroeder, we aim to supply the complete reservoir package. So that really cuts down on assembly labor and everything at your customer, unboxing, number of POs you have to place. So on this tank, for example, you'd have a PO for the tank, you'd have a PO for the filter, you'd have a PO for the breather, one for the level gauge, another one for the strainer, another one for the clamp. So you're taking 6 or 7 POs and reducing that to one for these things, and then it shows up on your dock completely assembled, ready to go. So there's some real value that can be associated to that. These are some, just some examples of tanks that we're able to do to help our customers save space. You see the one on the bottom with the municipal vehicle. You see this arc in the bottom of it here. That actually goes into the fender well of the truck to really help reduce the footprint of that tank on the vehicle. Other thoughts when we really get into this, there's also the ability to mold in coolers and everything to these tanks as well. This is for customers that have really, really tight space restrictions and want to get the most out of the space that they have on their machines. Typically, with the complexity of these Roto-Molded designs and everything that goes into projects like this, there's not a huge cost savings here by combining it all together because it is, like I said, so complex to put it together. But it will save you a ton of space, and a lot of our customers see the value of that on their machines. And when they're up against the things that they have to add on the engine package for Tier 4, that this is a good option for them. This is just an example of all the components that go into this and would show up from Schroeder as one complete package ready to be dropped into the machine. We also have what we call the TNK packages. We have a standard line of filters for those customers who, don't have the volume of tanks required to go into a completely custom design. We have a 12, an 18, and a 25-gallon standard TNK tank that is already Schroeder optimized design, shows up as one package, cleaned, ready to go. So We've just rolled those out this year, and it's been a very good product for us. A lot of small to medium-sized OEMs are jumping on this thing because they don't have to worry about the development costs or the tooling costs. It's something that they can plug and play right into their machine design. They get the weight savings versus the steel tank. They don't have the Roto-Molded tooling charges. The Schroeder's already paid for that up front, so it's a really good overall package for a lot of our small to medium-sized OEMs. Like I said before, we have no two tank optimization projects are created alike, so we've had more than 250 successful tank optimization projects since we started this program. So we have the experience. We really hope to be able to deliver those advantages in oil costs, reduce of the space and complexity of the system, as well as securing spare parts business by private labeling not only the elements, but we can private label the breathers and the sight glasses and the strainers and everything and help drive overall revenue back to those OEMs. So that really touches on what our total tank optimization philosophy is all about. With that being said, that's the end of my section of the presentation. Just want to thank you guys for your time. If you have any questions, like I said, my name is Jeremy Crookshanks. My name and phone number are all over the website. That being said, thank you.